has been started, what happens from there? Well, the systemd is going to kick off essentially all the other processes that will follow. And a lot of these processes, especially your first or your second process and third through 20, are all involved in setting up your interface for actually interacting with the different devices and just general setup for your interface. Such as process 2 is actually creating your kernel threads, and it's responsible for managing the kernel threads that are created after process 2 and by other applications. And some of these threads may be included in your process 3 to 20, which would be threads for essential daemons or background services. And you have your other processes later on, which were, let's say, 20 through 100, which are still some of the earlier daemons, which are just background processes for your computer upon startup. And at the end of the day, you don't have to confuse it any more than we already have, because your operating system or kernel is essentially just acting as a mapper between your different hardware devices, where memory is stored, what processes are needed. And it all kind of comes back to this root is how your normal interface that you're going to interact with from day to day. Everything's mapped to your root. Like if you have Chrome, your kernel knows how to do for you, map your Chrome back to the file it came from and the file that came from, all the way back to the root. And it can then know which devices are needed, hardware, etc., to use for that process. So it's all really an abstraction of your different hardware devices. And we can now, instead of focusing on all those other little details, we can take a process-centered approach to how integrated development environments work. So what the kernel is actually doing for this process in specific, while we can kind of just trust that the operating system developers managed our initial 1 through 100, 200, 300 processes correctly. So let's move